Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, you're going to be looking at electrostatic, okay? So now, I'm going to start this very, very lightly and then increase with the intensity thereof, okay? So now let's consider now our grade 10 work where now we said, okay, let us have a sphere. Let's have a sphere like that, or whatever metal sphere, something like that. Okay. And now, say now this one is a positive one, this one is a negative charge, okay? And say to us, okay, let us be in a position of saying, let's say this one. Oh, the other things that you need to, okay, let us say this, it is what? It has a charge of 3 times 10, okay, let me say 3 microcoulomb. You really use micro, let me use, okay? Then this one has a charge of maybe something like 6 microcoulomb, like that. The one that I wrote first, it was milli. What we need to be in a position is us being in a position of now converting between the units. Remember, we have now millicoulomb, which is now times 10 to the power of negative 3 milli. When you twist this m, it's going to be 3 like that, okay? Then we have microcoulomb. This micro looks a little bit like 6, okay? Like 6. So it's going to be times 10 to the power of negative 6. Then we have now micro p, milli, micro, nano for 9, Then the last one, pico, it is times picocoulomb times 10 to the power of negative 12 coulomb, like that. Okay. Now remember again, what is happening is that during these ones now, they will feel what they will feel an electrostatic force, right? So now that electrostatic force experienced now, it will now cause what? A force of attraction. We agree. There will be a force of what? Of attraction between the two. Okay. Yes. Now that force of attraction will cause now the object to do what? This object will now attract, right? Let me do it like this. This object will attract, let's say, here are my object, they are attracting, they are together like that. Okay. They are attracting like that. This is during the attraction force, okay? This is during the attraction force. So we still say this is positive and negative. What will happen? What will happen is that after on here, during this part here, there will be now transfer of electrons. Okay, there will be now transfer of electrons and charges thereof. But now, where will our electrons move? Our electrons will move from the most negative to the most positive one. So here we are saying there will be a transfer of electrons from the negative to the positive one. Okay, so there will be transfer of electrons there. After having a transfer of electrons, what will happen? They will come separate again, because now after transfer of electron, their charge will now be the same. Okay, when their charge become the same, now they'll be in a position where they now find themselves like that, and also like that. But now what will happen is that now there will be now a new charge that is identical for them. Why? Because now the transfer of electrons happened. Then after that, there was a sharing of electrons. Then they eventually had the same polarity or the same charge, which is positive or negative. Therefore, if now the charge is now the same or the polarity, is the same. Now they do what? Remember, when the polarity is the same, they move apart, they now attract, right? But we should be in a position of saying, okay, let us now calculate the new charge that they both have, the new charge that they both experience. So how are we gonna do that? We're gonna say, let us calculate the new charge on them. We're gonna be Q1 plus charge number 2. Therefore, we divide them by 2. Then we'll be in a position of saying, okay, the first one was what? 3 times 10 to the power of 3 times 10 to the power of -6. Remember, it is positive. Plus, what is charge Q? Charge Q, it is 6, but it is negative. Q2 rather, it is -6 times 10 to the power of -6, like that. Then you all divide that by 2. On this formula, it is acceptable to say now it is 3. It is acceptable to substitute it like this. Okay, it is acceptable to substitute it like this. Only on this formula though. Only on this formula. Okay, this is accepted. This is also this is also accepted to do that. But when we now deal with Coulomb's laws, no, we are not in a position of doing that. Therefore, now we will say, okay, the new charge between them will now be what? Let me take out my calculator. I think mine is going to be -1.5. Okay, yes. The charge will be now -1.5 times 10 to the power of -6 what? Coulombs. Now, can you see now both of them are now having a negative charge. So now they now have 1.5 times 10 to the power of -6, 1.5 times 10 to the power of -6, like that. Coulomb, like that. Okay. Now it might happen that the examiner asks you, calculate the change now, the number of electrons transferred. Okay. Now on number of electrons transferred, you're gonna say, okay, how can we find now number of electrons transferred? Number of electrons transferred is equal to change in Q divided by electron. Now we need to know the change in the charge first to see exactly how many electrons were transferred. To see exactly how many electrons were transferred, we need to know, okay, let us say the question says transferred during before during during the attraction force or whatever. So now we want to calculate the number of electrons transferred. Now, remember, electrons were transferred from I need to name this A, B. Remember, electrons were transferred from B to A. Okay, so now it means this one had a loss of electron, this one had a gain of electron. Now, when we want to calculate the number of electrons, we need to find the change in Q. Let's say for A, and here calculate change in Q for B. The change in Q should be the same because what I lose is what you gain. Okay. The change in charge will be now charge final minus charge initial. Also here it will be charge final minus charge initial. What is now the charge final of A? Charge final of A, and for both of them it is -1.5 microcoulomb minus the initial charge. The initial charge of A was what? Was 3 microcoulomb. We remember that, right? So sorry. So the change here, it is what? -4.5 microcoulomb, which is the same as a -4.5 times 10 to the power of -6. Okay. Now this one, what is its change? Its change is going to be Q final minus Q initial. Q final, it is -1.5 what? negative 1.5, what? Oh, microcoulomb minus of the formula. Then the charge initial of B was what? Was negative 6 microcoulomb. Can you see that? Now, when we do our mathematics, we get this one. It is 4.5 what? Microcoulomb. Why are we getting for B it is positive, for A it is negative, but the value is the same? It is because when B was transferring electrons to E, B became now less negative. Okay, B acquired more. When you lose electrons, you become positive. Okay, even though you might not become positive, it means now you are decreasing the number of electrons that you have. Okay, therefore it makes now the number of protons to appear more. Okay, but this one was positive. But now, as now the charge continues, what happens? So as the electrons have been transferred to it, what happens? What happens is that it gains electrons. Can you see now it gained electrons so that it becomes negative? This one lost electrons because initially it had negative 6 microcoulomb of electrons, but now it has negative 1.5. Okay, I do not need to say negative because already the signs are showing. So can you see the change was from here to there was a decrease in electron. So now hence a decrease in electrons is the gain of protons. So hence now it is like that. But now when they want the number of electrons transferred, if they are talking the number of electrons transferred for A is going to be Q, change in Q of A divided by electron, or if they want number of electrons transferred, it's going to be, for B, it's going to be N for B, number of electrons for B, it's going to be change in charge for B divided by an electron. Okay, or charge of an electron. Let me put it like that. It can be E or just E. Now, here, what is the change for A? The change in A is negative 4.5 times 10 to the power of negative 6. Divide, what is the charge of an electron? If the numerator is negative, you're going to say negative 1.6 times 10 to the power of negative 19. Then you get an answer. Here is going to be what? The change in here is what? It is 4.5 times 10 to the power of negative 6. Then the charge of an electron, if the numerator is positive, it means I'm going to substitute the positive number because now the number of electrons should be a positive answer. Therefore, let me punch my calculator and see what exactly we are getting there for both the values thereof. Therefore, it is now 1.6 times 10 to the power of negative 19. So therefore, you get something like, okay, we get something like 2,8125 times 10 to the power of 13 watt. You should say that these are electrons. Okay, these are electrons. Remember, the value should be the same for both of them. So it means A gained, what is it? It means A gained these electrons, whereas B lost these electrons. Can you see that? Yes, that's all. That's all that you should remember from grade 10. That's all. But now I want you to see something. What if we had a case now? I will erase it. What if we had a case now where both of them are positive? What if we had a case where both of them are positive and say, let's say this one had a what? 3 nanocoulomb, this one had a 1 nanocoulomb. So which one, the electrons were going to move from which one to which one? Remember when I started, I did not say the electrons move from negative to positive. I said the electrons move from the one that has more electrons than the other. So if they are both positive like this, which one has more electrons? This one has more electrons because there are few protons than this one. Here it has more protons. This one, it has less protons. It means now this one has more electrons, this one has less electrons. Okay, so we're going to move from the one that is less negative to that one. Okay, so this will where electrons will move from let's say this is B, this is A. So it means the electrons will move from B to A. Can we prove that with a calculation? Yes. Let's see Q nu that we get. It's going to be what? 3 nanocoulomb plus 1 nanocoulomb. This divided by 2. This will be the same as 2 nanocoulomb. Can you see now, after the contact, they now had positive charges, both of them. Yes, true. Yes, true. Okay. It is the same, positive, positive. But now, can you see the value of this one decreased to 2 nanocoulomb? The value of this one increased to 2 nanocoulomb. It means now, if this one had its protons decreasing from 3 to positive, it means this one acquired. Okay, this one gained electrons. Why? Because now its charge moved from more positive to less positive. This one lost, because if you lose more electrons, you are gaining more protons. So this one here had a what? Lost electrons. This one gained electrons. Hence, I'm saying the electrons will move from B to A. That's all. That's all. Now let's move to Coulomb's laws. Coulomb's law. We are seeing that, okay, the objects are moving together and what, all of that, it's fine. Now let us be in a position, okay, remember here, okay, I'll come back to that. You're in a position of saying, okay, let me have a metal sphere A and metal sphere B maybe, as well as metal sphere C, like that. Actually, let me start it like this. A, B. Let me say this is A, this is B. They have their charges respectively 2 microcoulomb, this one negative 5, negative 5 microcoulomb, like that, right? Then let's say they are displaced at a distance 0.1 meters, okay? That is R, okay? Now, let's say we are told that these objects come together, okay, then separate. After separation, okay, this was before separation, before and after, okay? Before separation, they were like that at a distance of that. We agree they will do what? Let's say they come together in contact again. After coming in contact, remember what will happen? There will be a transfer of electron. Remember, electrons will move from the one that is more negative to the one that is less negative. There will be a transfer of electrons like that, right? Therefore, after what they contact, after contact, what will happen? This one A, this one B. Therefore, there will be a new charge. Okay, there will be Q new there. There will be Q new. Q new will be something like 2 microcoulomb minus 5 microcoulomb divided by 2, which is going to be 2 minus this is 3, then it's going to be negative 1.5 microcoulomb. So after, it is now microcoulomb like that. Like that. We now know okay, let me say now, after contact, they move separate again, then they add charge C here. Let me remove this. They add charge C. Remember the distance between this one and this one? Still 0.1 meters. Let's say distance from this one to that one. It's something like 0.5 meters, maybe, whatever. Okay? Now, they say now, sorry, initially A and B were just seated there like that. Then after contact, they do what? They separate again with their new charge. Can you agree with me that their charge will be different? And we just calculated that this one will have a charge of negative 1.5 microcoulomb, negative 1.5 microcoulomb, right? Then let's say they place a C of charge C of a okay. After placing charge C now of charge, let me see if I say it is positive or negative. Okay, positive 3 microcoulomb like that. Okay, let us say the examiner says calculate the electrostatic force experienced by charge B. Now let us be in a position of calculating the electrostatic force experienced by charge B. What will happen? We'll say, okay, we need to know whether charge B, we need to know the force that charge B experienced due to A and charge B experienced due to, okay, here we need to calculate the net electrostatic force experienced by QB because QB will experience force due to A and due to C. How can we do that? We're going to say, okay, let us calculate now the okay, before we do that, we need to be in a position of defining Coulomb's laws. What does Coulomb's laws say? Coulomb's laws says, where can I write it? Let me take this one upwards a little bit. Coulomb's laws says the magnitude, okay, this is too much. Actually, let me do this. Let me see if I can move this one down, all of these. I need all of these to go down with me. Okay, so that we become in we are in a position of defining now what exactly is meant to us by electrostatic force. Okay, let me try to take everything there. So it's fine. We'll define electrostatic force, but maybe you should know the definition. Remember, Coulomb's law says the magnitude of the electrostatic force experienced per unit positive. I'm sorry. The magnitude of the electrostatic force experience. Yo, okay. The magnitude of the electrostatic force between 2 point charges, or whatever the definition that might be. Please know your definitions very well. Now we need to calculate what the net electric force experienced by QB. QB will experience what? We agree that QB will say force that A exerts on B because B will experience a force due to A. Okay, we'll say force that A experience on B, A exerts on B. It should be. Remember the formula for Coulomb's laws is Q K A B all divided by R squared. This is the formula thereof. Thereof, we'll say, okay, we need to, remember when you substitute here the negative sign, we do not substitute them. What is the K constant? It is 9 times 10 to the power of 9. Therefore, what is charge of A? Charge of A is 1.5 times 10 to the power of negative 6. Charge of B is this one. It is also 1.5 times 10 to the power of negative 6. Remember, we do not substitute the negative. All divided by distance squared. Remember, don't forget to say distance squared. Okay? Yes, let us be in a position of saying, okay, let's punch that into our calculator and see exactly how much we get. How much we get. Negative 6. Quickly do that. 0.1 squared Do not forget the squared. Now I get a force, an electrostatic force of 2,025. But I need what? Newtons. This is a force. I need to know force A causes force B to move where? Can you see this is negative, this is negative. So it means now force B is force A is causing force B to move. They will repel again. They will repel because now they are like charges again. So it means this one will move towards the right. Therefore, it will cause B to move towards the right. We are focusing on where B will go. B will move towards the right, okay? Therefore, between B and C, they're gonna do what? They're gonna attract. So B will move to that side, C will move to that side. So we are concerned about B. B will move towards C. Okay. So now when you calculate its force, you're gonna say, let us calculate force that C exerts on B. It should be K QC QB divided by R squared. Then we multiply, when we substitute like that, QC it is 3 times 10 to the power of negative 6. QB it is 1.5 times 10 to the power of negative 6. Okay? Then I need to divide by the distance squared. Distance squared, remember we said it is 0.5 thereof. The distance between the two is 0.5. Let me be in a position of substituting thereof. Okay? I'll quickly fix few things because now others are the same. I'll just change this 1.5 as 3. Therefore, I get something like 0.162 newtons. Okay? Yes. Where? To the right. It will cause this to go to the right. And now I want you to realize something. The distance between A and B, it is shorter than the distance between B and C. Now, from our formula says F is equal to KQ1 Q2 divided by R squared. If now the distance is greater, the force that we will be experienced is low. Okay? The force that will be experienced will be low. But if the distance is shorter, therefore the force experienced it is high. Can you see now? This is what is happening. From between A and B, the distance is shorter and the magnitude of the force it is greater. It is 2,025. But now between B and C, the distance is longer. Can you see the magnitude is 0.164, 162. Therefore, now we need to calculate the F net. F net will be force A on B plus force C on B. Let's choose right as positive. Therefore, force A on B, it is what? Positive 2.0 plus 0.162. Like that. Why am I saying they are both positive? Because they are going to the right. If one of them was going to the left, I was going to put negative on that before on that sign of that, on the sign of whatever value they're of. Okay? Yes. Therefore, I get something like 2.187 newtons. Where? To the right. Why? Because now they asked for the what? For the net electrostatic force. Okay, so this is the net. They did not say the magnitude, the net. So how do they mark this? They will mark this formula, substitution here, substitution there, coming into this part and saying, okay, I substitute this and substituting that 5 marks. Okay, yes. Before we move into two dimension now, that was one dimension, right? That was one dimension. I want us to be in a position of saying, okay, let us understand now between, okay, let me say this was one dimension. One dimension. One dimensions means now it is just horizontal or vertical. Let us be in a position of saying, okay, we also encounter two dimension, because now we have done vectors in grade 11 or vectors in 2 dimensions. So now this makes us eligible to understand this one. Let us say now we have a charge here. Okay, this is, let's call it charge B, and we have charge A. Okay, charge A here, And we have charge C there. Okay. And the distance between the two, it is something like 15 millimeters. I need to show you all the conversions because now I don't want you to be surprised in the exam. The distance between this one, it is now 10 millimeters. Can you see now? This is two dimension because now we are dealing with vertical as well as horizontal. Okay, yes. Now B, let's say it has a charge of negative 10 microcoulomb. Let me write it here, negative 10 microcoulomb. Charge C has a positive 7 microcoulomb. Charge A has positive 5 microcoulomb. Okay. We need to know, let's find now a resultant or net. Calculate the net electrostatic force on QB. Okay, so we want to know exactly the electrostatic force, the net, because it is the force that it experiences due to C, also a force that it experiences due to B, due to A, I mean. So now we want to know between B and A, what will happen? Between B and A, there will be an attraction, meaning B will move to that one. So this is force A. This is the force that A experiences on B. Causes a, so B will move downwards because now there will be force A. The force that A exerts on B will cause B to move downwards. But this one will have a what? This will be the force that B exerts on A. B will exert a force on A that causes A to move upwards. Okay, do not confuse that. Then between B and C, there is an attraction. So it means now this will be the force that C exerts on B. It will cause B to move in that direction. But similarly, here, this will be the force that B exerts on C. B will say, come to the left, let's meet. Okay. But now we are interested in what? In the net electrostatic force on QB. What other charges do to B? They cause B to move where? Okay. Yes. So now we see that force B, the forces that are acting on B, we are focusing on B, right? The forces that are acting on B will be now force that C exerts on B, and now moving downwards will be when I use a vector rule. Okay, what does a vector rule says? Head to tail method. Okay, so this will be the force that C exerts on B. Therefore, this will be the force that A exerts on B. We want to know what other forces are doing to B. So what will be the resultant force? Remember, the resultant force will be from where it started until it ends, like that. This will be the electrostatic force. This will be now our F net experienced. Where is our angle? Our angle will be between now where it started to where it ended. So this will be our angle theta, like that. Okay? Yes. Yes. One might start and say, okay, I saw the force of A first. Okay. I saw A moving downwards first. Let's call this force A on B. But also, head to tail method says now, okay, the force that C exerts on B will be like that. Something like that. You can draw it like this or like that. Okay. Then say this is for C on B. But now the electrostatic force will start, the net will start from where I started. Okay. Where did I start? I started here. Where did I end? I ended there. So this will be my, okay. Let me repeat that. This will be my net. This will be my net. Okay. My net. Remember, it's either you do the first one or the second one. Either way, they are correct. Then the angle will be this one. Okay. Yes. Then this will be 90 degrees like that. This will be 90 degrees like like that. So now it means now when we calculate the net force, it means now we'll have to apply Pythagoras theorem. Okay. And remember, if it is in two direction, you also need to find a direction. Okay. Now, let us be in a position of saying, okay, I'm going to use the first one. Okay. Either way, both of them are correct. They will give you the same answer. I'm going to go with this one. I'm going to say, okay, let me find now FC on B. The force, electrostatic force that C exerts on B, it is K Q C Q B divided by R squared, the R squared. Now remember, I need to convert this millimeter to what? To meters. So if I move from millimeter to meters, just multiply that value by 10 to the power of negative 3. If I'm moving from centimeter to meters, just multiply that value by negative 2. Okay, so here it means I'll say this is 15 times 10 to the power of negative 3 meters. Okay, here I'll just say it is 10 times 10 to the power of negative 3 what? Meters. Or you can say divide by 1000. Here, let me give it enough space. Here, you divide by 100, however you use it, okay? So I'm going to say, okay, what is the K? K will be number constant, which is 9 times 10 to the power of 9. Charge C. What is charge C? Charge C it is 7 microcoulomb. 7 times 10 to the power of negative 6 microcoulomb. Charge B, 10. 10 times 10 to the power of negative 6 microcoulomb divided by R squared. R squared, the distance between the distance between B and C, it is what? 15 times 10 to the power of negative 3. So it is 15 times 10 to the power of negative 3. Don't forget to square. Remember, the distance should always be in meters. Then I'm in a position of saying, let me punch that on my calculator. 7 times 10 to the power of negative 6. Multiply by 10 times 10 to the power of negative 6. All divided by 15 times 10 to the power of negative 3. Then I need to square that. I get something like 28,000. Let me see if I substituted correctly here. I get something like 2,800 what? Newtons. Now we need to know the direction. Where is B going? Because, okay, charge B causes B to move where? Can you see now it is attraction force? It causes charge B to move towards the right. So you're gonna say, okay, this is right. Okay, even if you do not do this immediately, I'll show you how to do this after that. Okay, I'll show you how to do that. Move to the right. Then what is force A on B? Okay, it will be charge A, charge B divided by R squared. Then this is 9 times 10 to the power of 9. Charge A, it is 10. Again, no, I'm lying. Charge A, it is 5. 5 times 10 to the power of negative 6. Then charge B, the one that is 10 times 10 to the power of negative 6. Divided by, what is the distance? The distance was 10 here. Again, we are talking between B and A. So the distance was 10. So it will be just 10 times 10 to the power of negative 3 meters squared. So I want to know how much value do I get? I get a value of 4,500 newtons. But now, where is force A on B? Force A on B, A causes A to move to B to move downwards. So I'll just say, okay, this is down. Then what do I need? I will say, okay, I need to draw a diagram so that I can see exactly what is happening. I need to say, okay, the first one is that this is moving towards the right. So I will have what? I will have force A, force C on B moving towards the right. And using head to tail, I will have force A on C moving downwards like that. Force A on B moving downwards like that. Now the net will come from, where did I start? I started here, I ended here. So that is where our net will sit. Our net will say, okay, I start here, then I end where? Okay, let me repeat that. I start here and I end there. So this is my F F net. Remember, our goal it is to calculate value F net. Where is my direction? My direction will sit here. I mean, my theta will sit there. Then this will be my 90 degrees. Okay. Then I'll say, okay, it means now I need the F net. I also need the theta. The theta will tell me the direction. Okay. Remember, it won't move upwards or downwards. It needs to move like that. So it means now the force that B experience, it moves like this in that direction because it causes it because some of the force is pulling it that way, some of the force is pulling it downwards. So the force should be between right and down. So hence I'm saying now, if this is right and bottom, the net should come between there. Okay, Luana, if you are being pulled, uh I don't know how to explain this, but if someone pulls you downwards and someone pulls you towards the right, can you see they are causing a mixture in your direction? It's not like they are pulling you towards left and right, where you'll say, okay, I'll move towards right because this one is stronger, or I mean towards left because this one is stronger, or towards right because that one is strong. Now they are exerting the forces on different ones. So also this one will be like that. So okay, we need to determine the direction. So we're gonna say, okay, the F net squared by Pythagoras is gonna be CB squared plus AB squared. I mean, am I in a position of substituting? Yes. I can say F net is equal to, or just square root this. I know it's gonna be square root of what? Square root of FCB squared plus FAB squared. Therefore, I'm in a position of substituting. F net is equal to square root of, what is this? Force of CB. When I substitute here, the direction is already taken account for that. Okay? CB, let me check. CB, it is 2,800. I square that plus AB, it is 4,500. I need to square that also. Then I get the F net as how much? I get the F net as something like 5,300. Like that. Okay. Then the question is on which angle, which direction. So for direction, I'm gonna say this is gonna be, I have this one which is my opposite, and I have this one is my adjacent. So I'm gonna use tan. So always tan theta, it is equal to opposite. What is opposite? Opposite is the force. Force AB divide, what is my adjacent? My adjacent, it is force CB. Therefore, it means if I want my theta, I can say tan theta. Okay, if I want theta, remember I'm gonna take the inverse of that. Okay, yes, the inverse of that. Then what is force A on B? So force A on B, it is 4,500. Then this one, it is 2,800. Then I get something like theta is equal to arc. Arc tan, remember you say shift tan, then of what, of 4,500 divide by 2,800. Then I get an angle of something like 58.11 degrees. The question is, how do I therefore answer this question? I need to know when I draw my Cartesian plane here. Do you all agree with me when I draw my Cartesian plane like this? This angle here, it is below the positive x-axis. Can you see that? When I draw my Cartesian plane like that, this angle here, I find it below, let's say this, my x, my y. Can I see? I get this angle theta below the positive x-axis. This x-axis is positive here. So I'm going to say, okay, therefore my F net, you need to conclude this is grade 11 and 12. Therefore, F net, it is equal to what? The value. What is the value? 5,300 newtons at an angle. At an angle of how much? Of 58.11 degrees below positive x-axis. Okay? Below the positive x-axis or you can say below the negative y-axis. Why am I saying below the negative y-axis? Because can you see the y here, it is negative, the y here are positive, the x here are positive, the x here are negative. So it's either you say below the negative x-axis, which I prefer. Let's use with regards to x-axis. Below the x-axis, positive x-axis, or that one. Yeah, that is it. That is it for that one. Let us be in a position of saying, okay, let us talk about ratios. Let us talk about ratios. What do I mean by ratios? We need to use this Coulomb's laws and say, okay, according to Coulomb's laws, we have F, it is equal to K, Q1, Q2 divided by R squared. We need to know if I increase the force, what will happen? If I decrease the force, what will happen? Let's say the first one, they increase double, let's say double the mass of, let me start by saying what will happen, what will be the new force? Electrostatic force. If, first condition, double mass of Q1, okay? The second one, the, what can I say here? Double radius C. I need to consider all options. C, double mass of both objects, of both charges. Oh, okay. Here I'm not talking about the mass because now this is electrostatic. Okay. Double Q1, double uh, Q1 and Q2 and half the radius. Okay. Number D, half Q1 and double radius or distance. Now let's consider number A first. Let's consider number A first. I'll come here and say, okay, for number A, I'll say for number A, all of them I'm going to do it here. What will be the new force? Remember, the original force is F, okay? So we want to know if the first one will be 1 over 4F, 1 over 2F. So if the original F is this one, what will be the new force if now we double Q1? If I double Q1, you agree with me, it's going to be F new is going to be K. I double Q1, it's going to be double Q1, then Q2 still the same, then divide by R squared. Then when I take this one to the front, it's going to be 2. It's going to be twice K Q1 Q2 divided by R squared. But what is this equal to? What is this equal to? This is equal to that. Okay, can you see that is equal to that? But that we also know this is equal to force. So every time when you see Q1 Q2 divided by R squared, you divide that, you substitute that by what? By F. So it means here it will be 2F because this part, it is equal to what? To F. So it means now what will be the new electrostatic force if we double Q1? If we double Q1 is going to be what? 2F. Now let us be in a position of saying for number B, we double the radius. Okay? We double the radius, it's going to be K. The charges remain the same, but now I double the radius, it's going to be 2R squared. Can you see? 2R, then I square everything. It's going to be what? K Q1 Q2 divided by 2 squared is going to be 4R squared. Can you see? But what is this? I can also rewrite this as 1 divided by 4 multiplied by K Q1 Q2 divided by R squared. Because if I multiply that by multiply that It's going to give me this. So this, what is this? This is F. So it means my new force will be 1 divided by 4 multiplied by the original force. Can you see? Let me just stop here. Can you see that if I increase the charges by whatever factor, force is increasing, Leon, I get. But if I double the radius, what will happen? The force decreases. Now I want you to take note of this. The force is directly proportional to the charges Q1 and Q2. If you double Q1, you double F, okay? If you double Q2, you also double F. But if you double both of them, it will be 2 multiplied by 2. This will be 4 times, okay? Then we get to realize that also force is inversely proportional to R squared, meaning if you increase this, your force will decrease. But by what factor? By what factor we will say, okay, if I double this, it's going to be double squared, okay? Because if I double this, I need to square that double. So it's going to be what? 1 divided by that number, which is 4. So it means this one will decrease by 1 divided by 4 by a factor of 1/4. Okay, can you see here? We doubled it, but since well, we need to square that, it means now it will be by the factor of 1 divided by 4. Always do the calculations, okay? Yes. Let us be in a position of answering the second one, okay? Let us be in a position of answering the number C. Double Q1 and Q2 and half the radius. So I'm doubling both. K, 2Q1. Remember, we are taking them from this original formula. 2Q1, 2Q2 divided by, I'm halving the radius, 1 divided by 2 R squared. Then what will happen? What will happen is that it's going to be 2 multiplied by 2, which is 4 KQ1, Q2 divided by 1 divided by 2 squared is going to be 1 divided by 4 R squared. Again, so but now I said do what? Take this one. Okay, you can say this is the same as, I don't want you to be exposed to mathematics a lot. 1 divided by 4. Take it as it is, then say this is KQ1, Q2 divided by R squared. What is this? What is this? That is force again. But now what I want you to do is punch this on your calculator and see how much you get. Punch this on your calculator and see how much you get. When you do that, you say 4 divided by 1 divided by 4. Again, you agree with me, you get something like 16. So it means now this will be 16F, because this is always what? F. Then 4 divided by this one is also 16. So how do we know? I can also say, okay, instead of saying it is 4 divided by 1 over 4, I'm going to say it is 4. Remember, it is divided by 1 over 4. When I apply tip and times, I change this to multiplication. If I change that to multiplication, I need to flip that one to 4 divided by 1. 4 multiplied by 4, it is 16. Divided by 1, it is 16. So it means now the new force, it is what? 16F. So the new force, it is 16F. Can you see now, when we have the radius, the force increases, because remember I told you if the radius is the distance is short, what will happen? What will happen is that the force that you experience will be greater, because now you're close to one another with that particular person again. But if the distance is apart, now the force is not that greater. Another part is that you can use an example of when you're in a relationship with someone. If you are close, now the bond is strong. Okay, the force that you feel each other is stronger. But now, if you are doing a distance relationship, now the force is there, but it is not much stronger as you are close to one another. Okay. The last one is half Q1 and double radius. Oh, half Q1 and double radius. Half Q1 and double radius. What is going to happen with, on that case thereof? What is going to happen on that case thereof? Let's see. We want to explore all these options thereof. This is just playing with the formula. Half Q1 and double radius. When I have Q1, is going to be K half Q1 Q2 divided by double the radius. Wait. Yes. Then now it's going to be 1 divided by 2K Q1, Q2. I'm just rearranging this. Then this will be 4R, R squared. Do you agree with me, Mara? This one you already know. What is this? This is F. This is already what? F. Therefore, 1 divided by 2 divide by 4, we get something like 2. So this one will be 2. So it means now our force will be 2 F. But I want to believe you are following 2F. So that is it from ratios that they like a lot this question on multiple choice questions. Yes. Now let's move on to electric field. All right. Let us be in a position of talking about now electric field. Okay. Let us be in a position of talking about now electric fields. Know your definition from the exam guideline. Remember, an electric field, it is what? A region in space in which now an electric charge experiences a force. Okay. A region in space in which now an electric charge experiences a force. Know your definitions very well. Okay, so now we need to know if a charge is positive, how do we see it? If a charge is negative, how do we see it? Okay, now let's draw single charges. For single charges, if it is positive, I have an analogy that says positive for Puma and then negative for Ngena. Okay, you should be in a position of understanding at least Sizulu here, because now the analogy that I created it in Sizulu, where I say positive for Puma, negative for Ngena. What do I mean? I mean now if it's a single charge like this, you need to draw something like, they should be very, very straight. I don't know why I'm failing to do something straight here. But this should be very, very straight with your ruler. Very, very straight and precise. Okay, now I don't know why. Yo, dim. Okay, maybe that is a little bit better. Then I'm gonna say, okay, let me do another one here, another one here, another one here, another one here. They should be of equal length. And now I'm saying, where is the electric field moving from? They are moving from positive to negative. So it means for positive, they will want to do what? They will want to move away. They want to Puma. So this is what we will draw for a single charge. If they say draw a charge for Q, if it is positive, you'll just draw this. Positive for Puma, like that. Positive for Puma, like that. Then you are done. For a single charge. Okay? If it is negative, you're having a negative charge. If you're having a negative charge, you will have now the same thing, but now instead of Puma ring, they will be doing negative for Ngena. So it means our field will be Ngena ring. Okay? They will be Ngena ring in there. Can you see now how straight they are? Very, very, very straight. Okay, therefore you're saying negative for Ngena, so therefore it means you can say they are Ngena like that. They are Ngena like that. You can place them anywhere. You can also say they are Ngena like that. They are Ngena like that. Anywhere you place them, but you should be consistent with what you are doing. They are Ngena. You can just also do arrow like this. This is also fine. Okay. But I choose to do this one. It's fine. Whatever you use, as long as you are doing a correct thing. That is the most important part. This is what you draw for a negative charge. This is a positive charge for a single charge. What if now we have unlike charges now attracting each other? Or this is for single charges. Okay, let me label this. Single point charges. What if now we have unlike charges? Okay. Unlike charges, what will happen about unlike charges? Remember, unlike charges, they do what? They attract each other. They're off. Okay. Yes. If I'm having unlike charges, they repel. So they attract, right? So I'm gonna say, okay, if they say draw the electric field for these two charges now, this will be my positive one, Let me try to do this. Fix my position of the laptop as well as the pen. Okay. So this will be positive charge. Then this will be negative charge, or however the situation is thereof. Then now what we will try to do, sorry, what we will try to do now, we'll be in a position of saying, okay, let us draw the electric field for both of them. Okay, for both of them, remember it will be in a case of, okay, the first one should be straight, the first one, only the first one. Let me repeat that. Only the first one should be straight, but the others should show, okay, we're gonna have a pattern like that there, going in that direction, and they should be equal. Okay, they should be. Let me not take it from the same point. Maybe from here to there. Can you see that? Can you see? This is what we refer to now as electric fields. They're off. Okay. Then maybe the last one here. Then maybe the last one there. Then these ones, remember what will happen? They will move from positive to negative, positive for Puma and negative for Ngena. So there will be some that want to go out, but they won't manage. So they will be doing something like that. They're off. Then this one can be straight, but there are others that will be in a position of wanting to go out again. Similarly, there will be those who want to come in again. Those who want to come in like that. Maybe you can do something like that. Do not make them straight, but you should show us, or they are moving from positive to negative, like that. They are moving in that direction. Then from Ngena, they are entering here, they are entering there, and they are leaving here. Puma, they are pumaring in there. Can you see? The electric fields are very, very, very important thereof. This is what is required of you when they say draw the electric field for both the charges. Okay, if they now repel, we will be in a position of saying, okay, it can either be positive or negative, okay? Whatever the case that might be. I'll say plus or positive, okay? Okay? Here we said unlike charges repel. Here we say, so unlike charges they attract, like charges they repel. Therefore, what will happen? There will be a force. Okay, this one is not equal. So it will be something like, okay, they will want to move, but now they will not be able to. Why? Because now there is a repulsion force like that. So there will be a repulsion force like that. Uh, I struggle to draw these ones, yes. I always struggle to draw these ones. Trust me, I always did. Let me see. Okay. Then they will repel like that. If this one straight, then this one like that. Just know how to draw these because, yeah. But one thing is that they unlike charges, they will do their repulsion thing there, okay? Therefore, whatever the case that it does, they're off, okay? If they are both negative, they will be pumaring. If they are both negative, they will enter in here, enter in there. If they are both positive, it means they will leave, okay? Yes. So let's now be in a position of saying, okay, let us talk about electric field at a point. Okay? Electric field at a point. So what is an electric field at a point? Now we're going to say electric field at a point. It is the electrostatic force experienced per unit positive charge placed at that point. So now if I'm having what is this? a charge here, charge Q, and I have a point charge, positive point charge, which is Q like that, or what? There will be a force between these two, right? There will be a force now between these two. There will be a force now between these two. But now, the electric field that this one feels, it is now, is the what? It will be now, okay, Q will be the charge that experiences, okay? Experiences the force from due to Q, this one. This Q, which we now refer to the point charge, it will experience a force due to Q, right? So now for a matter of that, it will experience also an electric field. Okay, remember, an electric field, it is the electrostatic force experienced per unit positive charge. So we'll say, okay, the electric field now will be the what? The electrostatic force, the magnitude of the electrostatic force experienced per unit positive charge. So this will be the electromagnetic field experienced by Q due to by this small q due to that big Q. Okay, this formula we really use it, but you need to know it. Where now we say E, it is the electric field. Okay, let me be in a position where you say where Q, it is E is the electric field. In what? In newtons per coulomb. Why are we saying newtons per coulomb? Because now this is what? This is a force in newtons. Then this is a charge. How do we write charge? Charge in what? In coulomb. So it is newtons divided by coulomb. So hence we are saying that, okay? Now, let's say maybe let's have an example saying now to us, charge B experiences a what? A force of 2 newtons due to what? To charge A. Due to charge A. Determine the electric field. Field strength at point B. At point B. So now the charge B experienced a force of 2 newtons due to charge A. Let's draw that. Let's try to draw that. Let's say now this is A, this is B, then this one is a positive 2 Coulomb, this one is negative 5 Coulomb. Then now we need to know, we are told that charge B experiences, the experiencer, we're going to calculate for the experiencer. So this one experiences a force of how much? Of 2 newtons due to charge A. So now let's try to find the electric field strength at point B. So we'll say, okay, E, it is equal to force divided by Q. You can just make small q. This will be the electric field of B experienced due to the force that B experiences. Okay, so we'll be in a position of saying, okay, the force is 2 newtons. Therefore, the charge there, it will be 5 times 10 to the power of negative 6. Do not include the negative also in this sign, there in this formula. Therefore, we get something like 4 times 10 to the power of 5 newtons per coulomb, like that. Okay, and remember, it is a vector, so it should have a direction to right. Why are we saying to right? Let me remove this. Why are we saying to the right? Because now these two, they do what? They attract each other, right? They attract each other. So now charge B experiences a force of 2 newtons due to charge A. Determine the electric field at point B. Okay, At point B, the electric field will experience not to the right, rather to the left. B will experience an electric field moving it towards that direction because now they are positive. They are all negative again. So it's gonna be to the left like that. Then that's all for this one. Now there is a formula again that we use saying, okay, now what we want to calculate now the electric field for the both of them. For the both of them, we now find ourselves in a position of saying, okay, or rather not necessarily for the both of them, for the point charge. Okay. This formula is the one that you're gonna use more. Okay, you're gonna use now this one more. Let's say now we have an object and an object. Maybe let's say point P. Point P, it is a point charge, okay, a positive point charge. Let's say this is plus 3 microcoulomb. Now let's determine the electric field at point P due to Q. The electric field, okay, at point P due to point Q is going to be now, I said point P is always a positive charge, okay? It is always a positive point charge. Why? Because it is the electrostatic force experienced per unit positive charge placed at that point. So this is always a positive charge. So how can we find the electric field experienced at P due to charge Q? We're going to say, okay, E is equal to AQ divided by R squared. Okay, therefore you're in a position of substituting. This is 9 times 10 to the power of 9. Therefore Q, it is 3 times 10 to the power of negative 6. Then the distance between the two now, we are told that it is something like maybe 5 millimeters. Remember, 5 millimeters is the same as 5 times 10 to the power of negative 3 meters. So I come here and say, okay, this is 5 times 10 to the power of negative 3 meters. I do not forget the square equal sign. Then I get a value of something like 1,08 times 10 to the power of 9. What? Newtons per coulomb. Okay? Newtons per coulomb, like that. Okay. Where is it moving? Where is it moving? This is positive, this is positive. Where will point charge move? Point charge will move to the, we want to know the electric field experienced due to point charge. Okay? At point P due to Q, okay, due to Q. So Q will cause P to move direction, then Q will move in that direction. So we want to know where exactly will P go. P will go to the right, like that. Okay. So yeah, that's all for calculating the electric field and all of that. Similarly, also here we have a graph for electric field and, okay, if I'm having E here as well as charge, what are they? Can you see now electric field and charge are directly proportional here. Electric field is directly proportional to charge, and the electric field is inversely proportional to R squared. So it tells me the graph for electric field and charge will be straight like that. Okay, but the graph of electric field as well as the square of the distance between the two will be now R squared and E, they are inversely proportional. So it will be something like so. They will decrease. It will decrease. But what if we said instead of electric field and R, by saying R1 divided by R squared. Now I want you to note this part. This one says E is directly proportional to Q. This sign tells you it is directly proportional to that, to Q. Okay, hence you are having a straight line. It also says E is directly proportional. Hear me very well. E is directly proportional. This sign is directly proportional to the what? To the inverse. Okay, so it is directly proportional to the inverse. Hence, now we are saying it is inversely proportional to R, but directly proportional to the inverse. So E and 1 divided by r squared will be a direct proportional relationship. Because now if we had something like this, it was supposed to be something like E is inversely proportional to r squared, to show you okay, these are inversely proportional. But now here it tells you it is directly proportional to the inverse, but inversely proportional to this, but directly proportional to the whole part. So yeah, those are the graphs that you should be in a position of knowing. Okay, of knowing. Yes, and this one will only be limited to one dimension, electric field. It will only be limited to one dimension thereof. So yes, that's all for electric field, grade 11 and 12s. So yeah, I will do more question papers on this so that we enhance our understanding. Okay, yes, thank you very much. Until we meet on the next video.